Hello guys, in this tutorial let us see about the basic generation of AM signals. So let's open the LabVIEW 2014 file, create a new VI editor, right click, create a while loop, then that make another make a simulate signal to generate the message and the carrier signals. So let's change it to 100 Hertz and here to 5000 samples per second. Make sure that simulate acquisition timing has been selected and click OK. Now make a copy of this and extend this up to frequency tab, and similarly here too. Now let's make another. Let's make the two knobs in the using the front panel. So in numeric, let's choose the knob and place it here. Let's make the value to 100 and rename this to message frequency. Okay, now center align, make it somewhat bigger, and make another copy for the carrier signal. So rewrite it as carrier frequency, change the value to 1000. Then create another knob to make a M coefficient. Since we all know that we need M coefficient for the amplitude modulation, let's create another knob, say M coefficient. Rewrite this value to 3. Now let's come to block diagram and wire up these connections. Place it here. Now wire the signal from the output of the knob to the input of the frequency, and the output of this knob to input of the frequency. Now right click and in numeric tab let's choose multiply, and now let's multiply this signal. So one to this and another to this, since AM into M into AM, right? 1 plus M into AM. Here it is message signal. So M into AM, and let's make another one. Just add up. So here to here. Here we can make another. Here we can make a constant. So create constant and 1. 1. So 1 plus M into AM, right? Okay. Now let's choose another multiplier. So multiplier and input to this. So here take the sine output and give it as input to the multiplier. See, now to adjust, so we can adjust the knobs and so that we can make the changes in the message frequency, carrier frequency, and M coefficient, right? Now let us make some indicators. So graph, so waveform graph. So make another copy, another one too. So change it to message. So this to carrier and this to modulated, and this one to modulated F domain, which shows the frequency domain graph. Let's delete this. And this too. Okay, now let's move on to block diagram. So first message signal, then comes the carrier, then comes the modulated signal, and then comes the modulated F domain graph. So now let's wire up the connection. So to see the message signal output, you have to take the output from this and wire the connection to here, and from carrier it's coming from here to here. Similarly, from modulated is this is the modulated output. So let's choose the wire connection from here to here and make a wire connection of F modulated. See, this is F modulated, right? So we have to make some component to be placed. So let's choose express signal analysis and spectral. So let me place here, and now see, make sure that these options are enabled, the magnitude RMS and linear one, not the dB, and click OK to proceed. Then wire up the connection. See, here you can see the error in signals, 2 ports. So let's choose the signal input port and given to the output of the multiplier, and output of this signal spectral measurement FFT to the input of the modulated F domain graph. Okay, F domain graph. So these are the connections. So now let me resize this. So see, you can notice that this execution run button is broken, since there is some compilation error. So we have to right click on this, create a control. Since it is a while loop, you must specify the stop. Okay, and now let's move on to front panel. So see, you can see here the stop value has been created. So now let's move it to here and make it more bigger. Okay, now let's run this. So we are running this. You can tune up the frequency of the message signal, let's say 40 hertz, and let's move on to the carrier frequency. As we know that carrier frequency must be greater than that of the message frequency. So you can see the carrier frequency is greater. Here it is 131 hertz, and now let's tune up the M coefficient so that you can see now the amplitude modulated waves have been generated successfully. So you can increase the message frequency and carrier frequency more. See, now you can get a clear picture of the AM waves. Right, see, we have a really good, beautiful picture of AM waves have been created. So now it is 1, the value of the M is 1. Now when we move to more than 1, you can see the oversampling has been occurred. You can see that the over distortions, these side lobes have been created, and it is the undersampling rate. So you can stop it now, make a change here by making it to value 500 so that you can see the clear picture about this. Now let's run. Now let me run this. Okay, so this is the video, shows the amplitude modulation, basic generation of amplitude modulation signals. And thank you for watching. Let me see in another tutorial of LabVIEW. Thank you.